Okay, so now, okay, on the previous video, we have sketched the spheres. Where the first one we have x squared plus y squared plus z squared equal to 9. So we have a sphere with radius 3, and the center of the sphere is at the origin, which is 0, 0, 0. Okay, so that is the graph. We have discussed on how can we sketch the graph, the sphere. If you remember that at the beginning of the lecture, we have discussed on the domain and the range, right? Okay, for two variable function. So now we want to relate. I mean, okay, before we relate the domain, range, and also the graph. So let's now we obtain the domain and the range for this particular equation. So now domain. Okay, so you can see that the function is not only z equal to, isn't it? On the previous example on domain and range, all the equation that we have is we always put z equal to, for example, square root of x squared plus y squared. But now this time, the x, y, and z, they are just on the left side, meaning that now you have to rearrange into the function z equal to f of x and y. Okay, so meaning that this one you need to rearrange. So in order to get this form, then you have to rewrite the z squared equal to 9 minus x squared minus y squared. Then you need only single z, meaning that you have to square root both sides. So when you square root both sides, you have square root of 9 minus x squared minus y squared. Okay, so since your original expression there is square here, meaning that when you do the square root, you can say that the right side here can be positive and also can be negative. So z can be positive and z can be negative. Why we just take positive or just negative? You look at the original expression. This is your original expression, meaning that if you put any value inside the z, so you can put any number, positive or negative. So the outcome still positive because we have square. So meaning that here we can say that z is any number, positive or negative. Okay, so that's why we have to consider both positive and negative of z. Okay, so now this is your function of x and y. Okay, so now we want to talk about the domain. Domain of this particular function is the set of xy where xy are real number. And is there any constraint there? Now we have a square root function, so everything in the square root there should be positive or 0. Okay, so we put the constraint, this one. Okay, or if you want to rearrange also possible. So this is your domain, or you can have, okay, I would say or, okay, either one, or the set of xy are real, and then now if you rearrange this expression, then you will get 9 minus x squared minus y squared greater or equal to 0. And when we simplify that, we have this one. Okay, then you can put squared plus y squared less than or equal to 3. Okay, so that is your description of your domain. Okay, okay, now range. Okay, range is the value of Z. Z are real number. So now based on your expression here, what can you say about this? Okay, if we just eliminate this one, meaning that the value always positive, right? Also can be 0. So you can say that Z is greater and equal to or equal to 0. But this one, there is also negative sign. So meaning that Z can be any number. Okay, but then remember, inside the square root, there is 9 stand alone. There's constant here. So meaning that there is a possibility, there is an interval of Z. It's not only can be negative, can be positive, and can be 0. So it should be some interval because we have 9 here. So now we want to find out. Okay, so now I rewrite the equation over here. Plus minus square root of 9 minus x squared minus 1 squared. Okay, so this equation can be rewrite into this one. Okay, so what can we say here? The value in the bracket is all positive, right? 0 is the smallest, and then 1, and then maybe I put 9, and then maybe 10. Okay, and can be many more. Okay, so there are infinite many numbers as long as they are always positive and also 0. Okay, so now if the value in the bracket is 0, so now your Z is plus minus square root 9 minus 0, so we got plus minus 3, right? And then when we put 1, if the value in the bracket is 1, so the value of Z becomes 9 minus 1, so you got plus minus square root 8, which is smaller than 3. And then if we put 9, so 9 minus 9, so we got 0. Okay, and we put 10, Z equal to plus minus 9 minus 10. So what's the outcome? Plus minus, and the value does not exist. Similarly, if you increase the value in the bracket, so you keep getting the does not exist value. So now because of the Z must be real number, so we just focus on the real number that we have, the real value. So you can see that the smallest of Z is 0 and the highest is plus minus 3. Okay, so what can you see here? You cannot say Z is 0 to 3 because Z also can be negative. So now what can you say that based on the result that we have? So we can conclude that, so this is not correct. So Z is lying between minus 3 and in between you will have a 0. And also you can have, because you can see that this one also plus minus. So the Z here can be negative as well. And the value of Z also can be 0. But X must be lying between negative 3 to 3. So that is your range. So then we put that constraint for Z. So we got minus 3 to 3. So that is your range. Okay, so here, based on the result that we obtained, now I want you to compare. Okay, so just take the your sphere beside this one. So now where can you see where is the domain and can you see where's the range? Okay, so this is your graph that you sketched previously. So now, okay, we're talking about the domain. So this is the domain. Okay, now I want you to sketch the domain, sketching the domain. So which is based on this equation, right? So what is the equation here? So that one is actually a circle. So that one is a circle. So x squared plus y squared. So I just put the equal sign first, 9. And you have the circle with radius 3. Y on y-axis plane. And this is 3 and this is 3. And you need to shade the area. So when you want to shade the area, you have to look the inequality here, less than. Now you have a closed curve. When you have a smaller than and equal to, meaning that you have to provide a solid line, and less than meaning your shaded area should be lying inside the circle. So now compare this with your sketching of your domain with this. So where is your domain actually? So your domain on y-axis plane. So and 3 here. So meaning that from your circle, from the purple circle, right? So now using this one, so the domain here is this one. So what is domain actually? So domain is the vision, the curve that you can see when you're standing on the Z or along the Z axis. So when you're looking down, so you can see this one, which is this one, and this is actually that one is actually okay, this one is actually your domain. Okay. So that is your domain. Something that imagine you have a ball. This is your ball, and when you are standing up here, okay, you're standing on the table and you're looking down at the on the ball. Okay, looking at the ball, and when you're looking down, so you can just see this one. You cannot see the ball because you're from the axis. So you can just see this plane. So that is called domain. Okay. And how about range? So look at your computation about domain. You obtain that you can say Z is between -3 and 3. So now where is the range that you can see? What is the range? The range is the value of Z. Just look at the Z axis. So you can see that the sphere here is always lying between -3 to 3 only for Z. Now we are talking about Z. So Z is lying between -3 to 3. Okay, so now can you relate what is the domain and what is the range? So domain is the plane, okay, the region that you can see when you are standing up here, okay, which is something on XY plane. And range is the value of Z. Okay, so hopefully you're clear with that. So now for the other two examples on the sphere that we have discussed, I want you to think about the domain and the range for that particular sphere.